So you might wonder what even is the point of expanding brackets using the binomial method, because it seems that this method takes like a lot less work. It only took us maybe, well, it did take me 3 lines. Even if you want to be slightly more pedantic, it probably wouldn't take more than 4. However, if you could imagine that this power was really, really, really big, that'd be quite hard to do, especially computationally. So trying to tell computers to expand this using this method for particularly large numbers. As well as that, I picked simple numbers and simple variables like just a single x and 1. But what about if we had something like this? So trying to expand this out by hand, probably the best way to do it would be have that thing squared times that thing cubed. Then you carry over things, and especially with the minus sign, it's easy to get trapped and sort of have an incorrect answer. So this is one example where we're going to be using the binomial coefficient, or the binomial expansion method. So how we're going to set this up is we're going to define one of the parts as A and another one of the parts as B. Now, a keyword or a key sentence to note in particular is this here. The idea of decreasing powers of x. Now, this is sort of typical nomenclature that's used when expanding brackets. It will either say in decreasing or in increasing powers of x. So you have to note that the x powers have to go from highest to lowest in terms of descending. So in terms of our setup, we're going to let a, i.e. our function going to the left, as x, and b, which is our function going to the right, as the minus 4y. Remember that the minus signs always carry over no matter what. Technically, when I was doing it here, I should have let b be plus 1 instead of just 1. So it's important to note the minus sign for this particular case. So x take away 4y to the power of 5. We're going to start with the row number, which is the power. Choose 0. So that means we're moving to the left every single time. So that gives us an x to the 5 times minus 4y to the 0. Plus 5 choose 1. We'll have x to the 4. So I'll have 4 movements to the left multiplied by 1 movement to the right. Plus 5 choose 2 times x cubed times minus 4y squared. Plus 5 choose 3 times x squared multiplied by minus 4y cubed. Hopefully you can see why it's a fairly algorithmic process after a while. So that's 5 choose 4 times x to the 1 times minus 4y to the 4. Plus 5 choose 5 times x to the 0 times minus 4y to the 5. So let's just expand all these out then. So a handy thing to note actually with particular binomial coefficients is a lot of them have a particular form that you can sort of memorize. So note that 5 choose 0 and 5 choose itself. Well, actually, sort of in generally. N choose 0 is equal to n choose itself, which is equal to 1. And n choose 1 is equal to n choose 1 less than itself, which is equal to n. So in the case of this, we have 1 times x to the 5 times that. So that becomes x to the 5. 5 choose 1 is 5. So we have 5 by minus 4 is minus 20. X to the 4 times y. Which, if we're considering in terms of decreasing powers of x, I would actually write the other way around. So I'd write it as 20y times x to the 4. Now, 5 choose 2. I don't know off the top of my head. I think it's 10, but it's always best to check. Yeah, so it's going to be 10 times negative 4 squared, which gives us positive 160. So I'll have 160 y squared x cubed. 5 choose 3 is also 10, but noting we're being multiplied by a negative 4 cubed. So negative something cubed is still going to be negative, so it'll be minus 10 by 64 is minus 640 y cubed x squared. Then 5 choose 1 less than itself is still 5. Then we have negative 4 to the 4, so it's going to be positive, so I'll have 1280 y to the 4x. And then here, 4 to the 5 is negative 1024, so I'll have minus 1024 y to the 5. So all we have to do is just write down our final answer. So x take away 4y to the 5 is x to the 5 minus 20yx to the 4 plus 160y squared x cubed. Take away 640y cubed x squared plus 1280y to the 4x. Take away 1024 y to the 5. So that's that bracket fully expanded. Now I probably did make some mistakes, so do let me know if I've made some silly errors in the comments.